After building a fiber optic system, it must be tested to make sure the system will operate within a certain loss budget. The budget consists of losses from items like connectors, splices, the fiber, and miscellaneous other losses. I have a small system that consists of 2 patch panels, 2 reels of fiber joined together by a chem splice. I will calculate what the individual losses are for each of the components that I have and sum them together so that I know what to look for when it's time to test. Let's start with the fiber. Obtain the foot marking on the cable closest to the connectors. In this case, it's 5,898. Also obtain the foot marking on the other end closest to the splice point. In this case, it's 5,668. That will give me the length of fiber on this reel, and I will repeat the same on this side. Subtracting those 2 numbers will give you the reel length for each reel. You add the 2 together, that should give you as the total length for my system. After obtaining the total length, I will consult the spec sheet for the type of fiber that I have to derive the loss per kilometer. In this case, it's 2.8 dB per kilometer at 850 and 1 dB per kilometer at 1300. Divide the total length by 3280 feet to give the length in kilometers, and then multiply the length per loss per kilometer to obtain the total loss due to the fiber. There are 2 ways of looking at connectors as far as loss goes. One is referring to the manufacturer specifications, and the other one is going by TIA/EIA standards. Referencing Corning Cable Systems spec sheets, these SC connectors should give me a value of 0.3 of a dB each. Add the 2 together, I get 0.6 of a dB. Going by TIA/EIA standards, which allow for 0.75 of a dB, add the 2 together, I get 1.5 of a dB. So I'm going to develop 2 columns, one for manufacturer specifications and the other column for TIA/EIA specifications. And the total loss is as shown below. With this number, you can now test your system. It's like a balancing act between the total number and the contributions from the individual components. The connectors, the cam splice, and the fiber loss. If any of those components contribute a greater loss than you budgeted for, then your system will fail. If they are all as calculated, then your system will pass. With this final number, we know what to expect when we go to test. I've already calibrated my meters, and I'm going to plug them in and see if we can confirm our calculations with the test meters. My test set is set to test at both 1300 and 850 nanometers. So I will expect 2 numbers, and I do have the 2 numbers. Most modern units have simplified wizards that walk you through the testing procedure, and in some cases are completely automated, and they can test the system for you. But it's nice to take a look behind the scenes once in a while. Remember to wear your safety glasses and also avoid looking at connector interfaces carrying laser light, which is invisible and can damage your eyes. And that's it for me. If you have any questions, please give us a call or send us an email at cablesystems@corning.com. And remember, Corning Cable Systems recommends getting training fiber optic installation. We offer a series of classes, of course, and we thank you.